When you try to picture a scientist, you know, building a really rigorous argument, what pops into your head?
Oh, I mean, probably complicated charts.
Right.
A whiteboard just covered in dense equations.
Yeah, exactly. And a whole lot of heavy academic jargon,
Yeah,
right? Feels incredibly high level.
very much so.
But then try to picture a kindergartner's brain.
Oh, boy.
Yeah, you're probably thinking about pure, unadulterated chaos like finger painting, running in
Have you
circles.
seen what a green crayon tastes like?
Exactly, eating the crayons.
Yeah.
So bridging that massive gap between, high-level scientific logic and a 4 or 5-year-old's chaotic curiosity.
Seems impossible.
It really does. But today, welcome to the deep dive because we're looking at this fascinating stack of sources. We've got early childhood worksheets, presentation slides, and a transcript from a teacher's instructional video.
And they are so revealing.
They really are. They reveal exactly how educators are successfully teaching children, like kids as young as 4, to argue like actual scientists.
It's incredible to see.
So our mission today is to explore how this brilliantly simple tactile framework is literally hardwiring the fundamental architecture of critical thinking in these young minds.
Hmm.
And perhaps more importantly, we're going to look at what you can learn from this exact same framework for your own daily decision-making.
Because it is surprisingly relevant to how adults process information. Honestly, we could all learn a lot from these kindergartners.
Right. Okay, let's unpack this
Yeah.
because we need to start with the problem.
Yeah, the overarching problem we have to tackle first stems from what educators call the traditional CER acronym.
CE.
Exactly.
Yeah.
Anyone who has taken like a high school or college science class in the last couple of decades has likely been drilled on this.
Oh, for sure.
It stands for claim, evidence, reasoning.
Right.
It is the absolute gold standard for building a logical argument. I mean, you make a statement, you provide the data to back it up, and then you explain the logical bridge connecting your data to your statement.
Which is great for adults, but if I try to imagine asking a 5-year-old to, like, provide evidence and reasoning for your claim,
You're just getting a totally blank stare.
a completely blank stare. The cognitive load of that is just massive.
Oh, it really is. CER requires executive function, logic, planning.
Yeah.
It asks the student to synthesize data, contextualize it, and articulate metacognition.
Which is basically thinking about how they are thinking.
Precisely. And for a kid whose prefrontal cortex is still very much under construction.
Right. They're barely learning how to read.
Exactly. For them, that kind of academic language is just an impenetrable wall.
So how do you get past that wall?
Well, this is why the sources point to this incredibly elegant solution. They take that daunting, abstract CER framework and they translate those exact same rigorous cognitive demands into tangible, physical actions.
Physical actions. I love that.
Yeah, they use a conceptual model built around something every single child intuitively understands, a traffic light.
The traffic light system.
Yes, they call it the tell, find, show framework.
Yeah. Tell, find, show.
The brilliance of the traffic light analogy is that it bypasses the need for complex vocabulary. It piggybacks on an existing semantic understanding.
Because every kid knows red means stop.
Right. Green means go.
And yellow means caution.
Exactly.
And the presentation slides in our sources show how the framework pairs those colors with specific actions, and they use these little visual icons to guide the student.
Yeah, the icons are key.
So the red light is tell, and it features a little icon of a brain. It literally tells the student to hit the brakes, stop whatever physical thing they are doing, think, and make their claim, like tell what you think.
Right, so that's your claim. Following that is the green light, which is find.
Fine. Okay.
And the icon here is a magnifying glass.
Oh, I like that.
Yeah. Green means go. So go look closely and find the proof in front of you, what you see. This is the evidence gathering stage.
So they're physically searching the stimulus for data.
Exactly. And then you hit the yellow light. Show.
Show. And this one features a pencil icon.
Yes, the pencil. It acts as a cognitive speed bump. It's telling the student, slow down, write or explain this, and make absolutely sure your evidence actually matches your claim.
Show how you know.
Exactly. Show how you know.
You know, I remember being in school and getting traditional writing assignments, and the absolute hardest part was just staring at a blank page.
Oh, the blank page is terrifying.
The intimidation factor is totally paralyzing. But this framework provides what the slides call I think it's a pre-built thought equation.
Yeah, it's a pre-built thought equation.
The worksheets actually lock these prompts together for the kids. Instead of a blank page, they just fill in the blanks of sentences.
Hmm.
It says, my answer is, then I see that. And finally, I know this because...
And that structure acts as an unfailing scaffold. It ensures the students are explicitly connecting their visual observation to their cognitive conclusion before they even put a pencil to paper.
That's so smart.
What's fascinating here is how this semantic color coding turns an incredibly abstract thought process, constructing a scientific argument, into a developmentally appropriate action.
Right. Because they are associating thinking with a red brain
Observing with a green magnifying glass.
and justifying with a yellow pencil.
Exactly. The brain relies heavily on visual cues to offload cognitive strain. By giving them these icons, educators are freeing up the child's working memory.
So they don't have to spend all their mental energy just remembering how to format an argument.
Right. They can dedicate all their brain power to the actual problem in front of them.
Okay, so seeing how that framework functions is one thing, but the true test of the system is watching it scale, right?
Absolutely.
Because we aren't just talking about a single grade level here. The sources map out an entire evolution of abstract thought.
From the very beginning.
Yeah, it starts with static objects, then it moves to physical dynamics, then it leaps to the invisible, and finally lands on pure spatial abstraction.
The rigor scales dramatically, yet the underlying framework remains perfectly constant.
Let's walk through that because the examples are so cool. At the earliest stage, transitional kindergartens, we're talking about 4-year-olds.
Very young.
Yeah. The stimulus question on their worksheet is simply, which food is healthier? And they have a picture of an apple and a picture of a pile of donuts with sprinkles and frosting.
A classic choice.
Right. Following the pre-built equation, the red light tell claim is, the apple is healthier.
Mm-hmm.
The green light find evidence is, I see the apple as a fruit. And the yellow light show reasoning is, I know that fruits make up a healthy plate.
Now, cognitively, at this TK level, the reasoning relies purely on visual categorization and prior knowledge.
Okay.
The student is just identifying basic categories, distinguishing a fruit from a non-fruit, to justify a claim about health.
So it's basically pattern recognition.
It is pattern recognition,
Yeah.
but it is entirely grounded in that rigorous logical structure. They are learning that an opinion about an apple must be tethered to an observable fact.
It can't just be, I like apples.
Exactly.
Wow. Okay, so moving from static categorization to physical dynamics, the kindergarten worksheet introduces an actual experiment.
This is where it gets fun.
Yeah, it shows a toy car being pushed by a finger. And the question is, will the toy car come closer to you or move away from you if you push it? So the student's red light tell claim is, it will move away from me. Their green find evidence is, I see that it moves away from my body as I push it.
Right.
And then the yellow show reasoning ties it together. I can push other objects and they move away from me.
The reasoning leap advances significantly here. The child isn't just naming what something is anymore.
Right.
They're observing a direct physical action and then generalizing that physical rule to other objects.
Based on like hands-on observation.
Yes, empirical observation. From a single data point pushing one toy car, they are establishing a foundational Newtonian law of motion.
A 5-year-old doing Newtonian physics, that is wild.
It really is.
But physical objects you can touch and see are one thing. The real test of this framework is whether it can help a child explain something entirely invisible.
Yes.
And that happens in first grade. The sources show this represents a massive jump in cognitive demand. The stimulus question is, why does tapping on a bucket make a sound?
Such a good question.
So good. The tell claim is, you make the bucket vibrate when you tap on it. The find evidence is, I see that when I tap on something, it makes it move or vibrate. But the show reasoning, this is where it gets incredibly heavy for a 6-year-old. It says, I know this because vibrations are what create sound.
Just think about what is happening there. The student is connecting a visible vibration on the surface of a bucket to the invisible creation of sound waves traversing through the air.
It's blowing my mind a little bit.
They are applying a complex physics concept to a rudimentary observation. They're bridging the gap between what their eyes can see and what their mind knows to be true.
So what does this all mean? Because I have to be honest, looking at these highly structured color-coded boxes and these rigid pre-written sentence starters,
Yeah.
I can't help but worry we're just turning kids into little compliance machines.
Yeah.
You know? Science is inherently messy. It's chaotic. It's about breaking things to see how they work. Doesn't forcing a kid into this paint-by-numbers formula should sort of stifle their natural chaotic curiosity?
I see where you're coming from.
Like, are we boxing them in too early just so they can pass standardized tests?
That is a very common and very valid critique of scaffolding in education.
Mm.
We naturally recoil at the idea of putting a rigid structure around a child's imagination.
Right. It feels wrong.
But the video transcript in our sources addresses that exact fear beautifully.
Yeah.
The teacher explains that this framework isn't about memorizing facts or just checking boxes to please an adult.
Okay.
It is about building instinctive scientific habits.
Okay, an instinctive habit implies it becomes second nature, like muscle memory.
Precisely. When a child learns this system, eventually, whenever they see green, they instinctively know to look for evidence. When they see yellow, they inherently justify their claims. It doesn't stifle curiosity, it channels it.
Channels it.
Think of it like giving a tomato plant a trellis.
Okay, a trellis.
Without the trellis, the plant grows chaotically along the ground, tangling up and eventually rotting in the mud. The structure of the trellis doesn't stop the plant from growing.
It gives the plant the support it needs to reach the sun.
Exactly.
Yeah.
This framework demystifies science entirely. It shows these kids that science isn't just about knowing big, intimidating words. It's a reliable, repeatable way of asking questions and finding solid answers.
So it gives them the tools for how to think, not what to think.
Exactly.
I love that trellis analogy. It takes the chaos of childhood curiosity and directs it upward into rigorous inquiry. And having seen the students master invisible cause and effect with the sound waves, the conversation naturally shifts to the ultimate cognitive hurdle.
The big leap.
The big leap. Because by second grade, the tactile evidence is entirely gone. We have a worksheet here where the stimulus is a world map and a compass rose.
Right.
The question asks, if you travel from Antarctica to Africa, which direction are you traveling?
Now let's look at the framework. The tell claim is simply north.
Okay.
The find evidence is, I see that you have to move upward from the bottom.
Right.
And the show reasoning explains. I know this because the compass rose shows south at the bottom and north at the top.
It is wild to think about what is actually happening in a 7-year-old's brain when they do this.
It really is.
They are no longer observing physical objects like apples or toy cars or even vibrating buckets. They are taking a 2-dimensional symbol printed on a piece of paper and using it to represent a 3-dimensional spherical planet.
It is a massive leap in spatial abstraction. They had to synthesize visual movement on a flat plane with standardized geographic tools and diagrams. They are applying a universal geographic rule to an abstract model of the entire world. And they are doing it effortlessly because the tell, find, show structure provides the cognitive safety net they need to make that leap.
Here's where it gets really interesting.
Yeah.
The presentation slides provide this graphic called the evolution of scientific vocabulary. And it's drawn like a staircase.
I love this part.
It's so cool. It maps exactly how the required vocabulary transforms as the cognitive demand increases across these grade levels. So at the bottom of the staircase in TK, the word bank consists of everyday language. Healthy, food groups, fruit, vegetables.
Very basic.
Right. Stepping up to kindergarten, we get action words. Push, closer, away. Stepping up to first grade, the language suddenly shifts to highly specific scientific terminology. Vibrate, wave, sound, tap.
A huge jump.
A huge jump. And finally, at the top step in second grade, we see navigational jargon. North, south, upward, compass, rose, map.
Now, giving students the grammatical structure via the tell, find, show framework actually allows them to adopt that advanced vocabulary.
Because they aren't panicked about the writing part.
Exactly.
Yeah.
Because they aren't spending all their mental energy trying to figure out how to build a coherent paragraph. They have the cognitive bandwidth to experiment with words like vibrate and compass rose.
Wow.
The framework holds them steady while the rigor scales up around them.
You know, it's funny watching a 5-year-old master this because I have to admit, I sat in a corporate strategy meeting yesterday where half the adults in the room completely failed to do this.
Oh, without a doubt. We see adults skip straight from read to running their mouths all the time.
Right. If we connect this to the bigger picture.
Yes.
Yeah.
If we connect this to the bigger picture, it becomes incredibly relevant to all of us, you as the listener.
Yeah.
We live in an era of absolute information overload.
Yeah.
Every single day, whether you are scrolling through social media, watching the evening news, or sitting in that exact corporate strategy meeting you mentioned.
Painfully sitting there.
Right. You are bombarded with arguments. People make incredibly bold assertions without ever stopping at the green light to find the proof, or the yellow light to show how the evidence actually supports their claim.
They just live perpetually in the red light.
Perpetual red light.
Tell.
Oh.
Tell. I know this is true because I said it.
Exactly. And that proves that critical thinking isn't just some innate talent you were born with.
It's a habit.
It's a structural habit that has to be practiced. These 5-year-olds are actively hardwiring a skill that many highly educated professionals still struggle with.
Wow.
They're learning to anchor their thoughts. By shifting away from abstract acronyms like CER to tactile cognitive tools like a brain, a magnifying glass, and a pencil, educators aren't just teaching children how to pass a quiz.
No.
They're literally physically wiring the fundamental architecture of scientific thought into their developing brains. They are giving them a repeatable process they can take with them and use on any problem they ever face in any subject for the rest of their lives.
They are making sure these kids are ready for the rigor of tomorrow, today. It completely redefines what a simple worksheet can actually accomplish when it's designed with the human brain in mind.
It really does. And this raises an important question, and it leaves us with a really powerful challenge to consider based on the ethos of these sources.
Okay, all right.
The tell, find, show framework works because it forces a pause. It inserts friction into the thinking process.
Friction.
You have to stop at the red light, look through the magnifying glass at the green light, and pick up the pencil at the yellow light. But think about the digital environments you interact with every day.
Like social media.
Yes,
Yeah.
social media algorithms are deliberately engineered to eliminate the green and yellow lights entirely.
Oh, wow. Yeah.
They are designed to be friction-free.
Yeah.
They want you reacting, not thinking. They reward immediate, unverified red light claims because outrage and bold assertions drive engagement much faster than evidence and reasoning ever could.
That's so true. The platforms actually penalize you for slowing down to look for the magnifying glass. By the time you found the evidence, the news feed has totally moved on.
It's long gone. So the next time you are scrolling through your feed, or you find yourself making a bold claim in an argument, I want you to view that moment through the lens of this kindergarten framework.
That's a great exercise.
Are you allowing the algorithm to subvert your own scientific method? Are you running a red light just because the platform made it easy to do so?
Probably.
The next time you feel the urge to just tell, challenge yourself to find the friction again. Demand the find, the show, not just from the people you are reading, but from yourself.
I love that.
Because if a 5-year-old can pause to gather evidence about a toy car, you can certainly afford to do the same before making your next big point.
It's a perfect reminder that the foundation of a rigorous argument isn't complicated jargon. It's just the discipline to stop, look, and explain. Thanks for joining us on this deep dive.